Dear students and viewers, in this video we will see how to do the dot product of vectors and how to get the component of a vector in two mutually perpendicular directions or the two dimensional coordinate system. So, for that we will use the algebra view, and here I am using GeoGebra geometry. So, here first I will define the origin. So, that is the starting point of the vector. For simplicity we will select the origin as the starting point. You can take any other point as the starting point, that will not matter. So, point O. Next we will select point P. So, point P is a 3, 4. Okay. So, this is the point. Next we will define the vector. So, vector is a V. So, V is equal to vector command we will use. So, vector command. So, as I write it comes, so that means this is a defined function. So, vector point and vector starting point and end point, that means if I use simply point, then it will require the end point only, and if I define by starting point and end point, then I will have the option to give you 2 points. So, if I use this, then the starting point is by default the origin. Okay. So, I will use this one. So, starting point is say O here and the end point is P. So, it is the vector. So, first I will select this and I will change the color suitably, so that you can easily see, and then I will select, or I will use a different thickness so that it will be visibly clear. So, this is the vector. Okay. Now, we want to decompose this vector into x direction and y direction. So, it is the x direction horizontal and this is the y direction in the default setting. Now, for that we will use the dot product command. So, dot. So, for that, so I will write Vx. So, V, say for example small v underscore x, it will give you a subscript. So, Vx is the magnitude, therefore, because it is dot product. So, dot, I will write dot. So, when I write dot, it gives you dot. So, it will require dot of two vectors. So, vector and vector. So, first vector is this vector for which I want to know or determine the component, or I want to get the component of this vector along this direction. So, first vector will be this vector. So, what is that? V. The name of the vector is V, so I have to use that. So, capital V, and then here what is that vector? In this direction. So, either I can use like say 1, 0, 0, that means the unit vector along the x direction, or simply I can write unit vector. So, for the x direction I will show with 1, 0, 0. So, it will give you this. So, as I write, so real time it is calculating to be 3, as you know that it has the point P has the magnitude of in the x direction 3 and y direction 4. Okay. So, I am using this. Okay. So, you see that as I write, it is showing the dot, but after I give enter, then the dot term may vanish. Okay. Simply it gives you V and 1, 0, 0, that means that is the dot product of V and 1, 0, 0. Now, you see that Vx is a dot product, so it is a scalar, that is because it is scalar product. Now, if I want to know the vector component, so I will use Vx. So, capital V x, that is a vector component. So, how to get it? I will write small Vx multiplied with, that means the unit vector. So, unit vector, you see unit vector. Unit vector object means along which direction it is the unit vector. So, x axis, right. Now, you will see the vector will come. Yes, you see that Vx is coming, but it is obtained with simply this one. So, I will now use a vector command. So, simply or you can use this here vector command. So, vector which one? Start point and end point. So, start point means it is O and end point means simply Vx. So, that is this one. Okay. So, here is this one. So, for this I will select a different color. So, say blue having different thickness, but here I will prefer to use say dashed, so that it gives you an idea that this is a component. Okay. Next I will show you how to get the y component in the same way, but I will prefer to write all these things in a more compact way. So, how to write that? So, in the same way, so v small vy, so small vy, so better if I combine these two in a single, so it will be v underscore y, that is, or if I write simply vector, then if I use that is this start point end point. So, start point is this one, zero. Better it will be to go for the formal or traditional way, so that you can follow easily. So, v or I just repeat this so that it will be easy for you to follow. So, v y is equal to v dot v and here unit vector y axis. Okay. So, that is the magnitude along the y direction, that is the component magnitude along the y direction. Now, again vector, so it will be v capital V y, so it will be this Vy multiplied by the unit vector along the z direction. This multiplication is simply a scalar multiplication, not scalar product, it is scalar multiplication, simply that means multiplication of a vector by a scalar. So, scalar is this one and the unit vector will be the vector. So, it will be v y multiplied with unit vector y axis. Okay. So, this will be this one, right. Next vector. So, start point end point, so it will be simply this one, start point is O and end point is V capital Y. Okay. So, this one. Now, let us just have some different colors, let it be say green and it is having some more thickness. Okay. So, what was the thickness here? 11. So, let it be 11 also, 11 and then it is this. Okay. So, these are the two components of the vector, that is the vector resolution in 2 dimensions. So, we can draw perpendiculars and check. So, for this I can take this. So, perpendicular line you can see. So, from this I can draw a perpendicular on this line. So, it is this as it is passing through this point, and from this I can draw perpendicular on this line that passes through this. So that satisfies that this is the orthogonal component. That means the blue one is the orthogonal component of this vector along the x direction, and this green dashed line with arrow is representing the orthogonal component of this orange vector along the y direction. So therefore, with this video you could know how to resolve a vector in two-dimensional orthogonal coordinate system and the use of the function dot product in GeoGebra application. Thank you for watching this video.